So, hello everyone, and thank you for joining us today for our CM Hurricane and Short-Handled Puller Load Brake Inspection webinar. My name is Gisela Clark. I'm the Social Media Specialist at Columbus McKinnon Corporation and will be your host for today's webinar. Presenting today is Peter Cook. He's our training manager. He specializes in rigging and load securement. Peter has devoted 15 years to Columbus McKinnon as an engineer, designing engineered lifts, slings, and forgings. He's traveled throughout the world teaching proper rigging techniques, rigging gear inspection, and hoisting crane inspection and maintenance. As I said, we are recording the session today, and the recording link will be added to our YouTube channel. Everyone in attendance will receive a link to the recording later this afternoon. As I also mentioned, everyone is in listen-only mode, so we encourage you to ask questions in our Q&A pane on the right-hand side of your page, the bottom right. We'll take 5 minutes at the end to address all your questions, and those we don't get to, if there are quite a few, Peter will personally respond to after the webinar. So thank you for your attention, and again, for those of you who have not tested out the Q&A pane, feel free to ask questions during the session, and we will take them at the end. So we appreciate your attention, and now I will turn the meeting over to Peter so that we can begin.
Hi, thank you for attending the webinar today, and we'll get right into it. So today's topic will be is how a hoist load brake works. We need to know and understand how it works in order to inspect it, identify the parts in a load brake, and we're going to focus in on the Hurricane 360 and the short handle puller. So we're going to show a disassembly of each one and how to inspect each one and how to reset it. When you're done, and I'll take questions at the end. So hopefully this is informative to you and get a little bit more comfortable utilizing our hoists. So Weston type load brake, what does that mean when you hear the Weston type load brake? Well, it's actually a gentleman's named Thomas Weston, who's an engineer who designed it close to around the turn of the century. And it's used in many modern, the concept is used in many modern hoists today, and it's a very unique design. I'm sure he didn't get much for his design, but it's used even today. The design was an excellent design and really revolutionized the industry for moving material and handling. So what is the makeup of a typical Weston brake? Well, a lot of people, what's the difference between a lever tool and a chain fall and the manual hoist? And really not much. It has the Weston type brake. This is pretty much the makeup. You'll see that you're going to have either lever tool or hand wheeled, or in the brake hub, friction washers, and then you'll have the ratchet and bushing and pawls, and then a friction hub at the end. So that right there is really the exploded parts view of a Weston type brake and what it looks like. And I'll get into how it operates and how it functions. Here you can see an actual hoist mechanism for a 640 puller, where it shows the brake hub or cam sandwiched in between 2 friction discs and a ratchet. And then what's going through all that, you can actually see the load shift or where the chain rides up on there, and that's a pinion shaft going through all that. And so again, that's kind of another view of it there in a real life view of a 640 puller. So how does this work? Either as you lift the load, either by operating a lever or pulling the hand chain, it causes the hoist load shift of the chain sprocket to rotate, therefore lifting or pulling the load chain. The load shift is connected to the Weston style brake components. So as you're realizing a force, it causes the brake components to squeeze together, therefore not allowing the load or force to slip or lower while engaging the ratchet pawls. So the braking components, they're squeezed together while you're raising it, which ends up holding the load. So the ratchet and pawls, you got friction working for you, and you have a ratchet and pawl mechanism that's also holding the load. So as you're either cranking on the lever or raising the hand chain in the raise mode, it'll squeeze together. So when you're lowering in the opposite direction, therefore lowering or releasing the load, it causes the spline shaft or pinion to rotate opposite of the lifting rotation and causes the brake components to decompress or loosen, allowing the load or shift to move in a downward direction. But the gapping when you're opening is so minute that the friction discs actually control the descent of the load, and as soon as you stop operating that unit, the weight, it's kind of self-locking. It kind of all squeezes back together and holds the load. And so really you're really having all these mini free falls, but it looks like a smooth operation the way the brake works. So it seems very smooth, but that's pretty much what you're doing is you're opening the brake, very, very minor gapping, and the load is coming down, but at a very controlled descent. And so it's a great design use throughout the hoisting industry. And hopefully I explained that as best I can for you in a visual and in a literal manner. So let's take a look at the CM Hurricane 360, and this is the latest version of the CM Hurricane 360 that we have launched about a year ago, and it incorporates the West Break to just get you acclimated to the Hurricane. It can go all the way up from half to 10 ton. It has standard lift zinc-plated chain used in power plants, boiler repair, refineries, and factories, wind turbines, pretty much wherever you can use a hand hoist in a maintenance situation, a production situation. A hand hoist can be used. What's nice about the Hurricane 360 is it's the only hoist where the chain can rotate. The hand chain can rotate in any direction, so you can stand well away from the load, where a typical chain fall, you have to be right close to the load. So it's very unique design and very, very safe for operators to use it. And you can see some of the features and benefits of that hoist. So let's break into that hoist. So the first we do is we get an Allen wrench. We're going to remove, you can see there on the top of the hoist, on each corner, we're going to remove 4 Allen head screws. And then we can undo that top, and as you can see in the picture below, you'll see there's the hand wheel exposed. And that's what we want to get to. And then we want to, once we do that, once we get that cover off, we want to seat 2 of the Allen screws back down just to hold everything together. So as we're looking at the brake, we do not pull anything else apart. So I recommend taking 2 of the Allen screws in each of the 2 corners and screwing them back in while you're doing your brake inspection. So what are we looking at underneath the cover here? Well, we have the hand wheel, of course, and then we have that pinion shaft that I just talked about that goes through the Weston style brake, and that is secured with a castle nut and cotter. And then below that cotter key there, you see there is the load limiter groove nut. So that's for the load limiter. We're not going to talk about load limiters today, and really for a brake inspection, we don't have to touch the load limiter. So that what the load limiter does is it prevents excessive lifting excessive load. So what will happen is if you lifted too heavy a load, the hand wheel would slip around the load brake and would not allow, it wouldn't compress anything, so it wouldn't allow you to lift, and it's really you're slipping the hand wheel, so it won't allow a lift to happen. And so it's prevent gross overload. But in this presentation, we're not going to really get in depth to that. We have another series coming up next month that we'll talk about setting those load limiters. So the first step we want to do is remove that cotter key and that castle nut. And again, we're not going to loosen that large black nut that we see for the load limiter. And I'll just highlight here, we do not, this black nut here, we do not want to loosen. Okay, so take that cotter key off, and then you can, by hand, you can undo the castle nut, and that'll get you into the next level of the hoist by being able to take that hand wheel off. So while holding the chain, we can counterclockwise, we can unscrew the hand wheel, and that whole hand wheel will come off. You hold the chain, unscrew it counterclockwise, and that will come right off here. So there we see the Weston brake exposed. And so behind it or underneath that hand wheel is what we have a braking surface there. You can see that's the brake hub. Okay. Then there's the pinion shaft going through, and then the friction disc, ratchet and pawl, and then the ratchet, you're going to see the exact same thing underneath it, another friction disc and another brake hub. So the first thing we want to do in our inspection is look at that braking surface, and we want to look for any types of contamination, excessive scoring, rust, anything that's drawing our attention. We also want to be sure that any threaded shaft, so that internal thread, now we don't like to get oil definitely on the braking surface, but when we teach, a lot of people think, oh, no oil at all in this section, and that's really not the case. Those threads do need to be lubricated, but a very light film, because you want the brake to open and close easily, and if it is got any rust or if it's binding at all, it won't operate correct. So too much oil, yeah, it would be a bad thing, but just we want to be sure that there is some lubrication on the threads, on the pinion shaft threads, and the internal threads on that hub. But make sure the braking surfaces are free from any contaminants, and you want to clean that up as best you can when you're doing your inspection. So next thing we want to look at is the friction discs and the ratchet, and we're going to inspect the conditions of those. Okay, so let's look at the friction disc. We're looking, again, for any contamination, and then we got what's called glazing, and glazing is a glassy type surface, so if a hoist has been used Naturally it'll become glazy or like a glass type surface, and that's really, we don't want to see that. So what we do recommend, on a really fine grit sandpaper placed on a table, just kind of rough them up a little bit before you put them back in, and then you want to check for wear or cracking and things of that nature. So in each of the maintenance books, it'll tell you what the minimum thickness of those discs should be, and so there you can see the capacity of the hoist that you have and the minimum thickness those discs can be to be safe for operation. Because as those wear down, that, of course, that gap, as when I talked about the Weston brake, as you release the gap, if there's not much friction surface there, the gap gets larger, so the hoist, obviously, the load will start to drift more. So as you stop that operation, it takes a little bit, you want that instant stop, and that's what you have the right thickness of the friction disc to be. And if you don't have that instant stop, and I'm not talking, it's going to be what's called a load drift. The load will creep down slowly, and that's showing that it has to overcome too thin of a disc to grab on, and so that's a clear sign that there's something wrong with the brake, or the friction discs are worn out. Next, we want to look at the ratchet, and it's a metal braking surface, so we want to be sure that's cleaned up. Oh, by the way, on the just to go back 1 second on the friction discs, we do not want to use any cleaners whatsoever on the friction discs. You don't want to spray them with anything, so no brake cleaner at all on the friction discs. On metal parts such as the ratchet here, you can just make sure you wipe it up so you do not contaminate the friction disc. So again, excessive scoring or any type of wear, check out the ratchet teeth that they're not peened over or chipped or missing, because we do want good pawl engagement, because that's what also aids in holding the load. So take a look at everything, especially that bushing. That's what the pinion shaft's riding around, so that can wear. So we want to check the wear in those bushings as well. And if we see any type of wear, if you're seeing it with anytime you're in doubt, you're going to replace the components. And then as you're moving down, we'll look at the threads on that pinion shaft, the pressure plate or disc, and then the condition of those pawls that are there. So look for damaged threads. Again, lubrication is important on those threads. Very light film. Again, if we go crazy, that will leach onto the friction disc, so we just want to do a light film on there. So we want to ensure the brake is opening and closing properly. There's a small clip that holds that pinion shaft in place. Make sure that's seated properly, and it's there, that it's not very loose or anything like that. And then again, check out the pawls. Okay. So we want to get rid of any excessive dirt. Sometimes you'll see some brake dust, especially if the hoist is being used heavily, so you want to wipe away any brake dust, things of that nature. Check out the springs. Are the pawl springs are working correctly? Are they seated properly as well? So you could find out that, oh, wow, it's a pretty loose spring, and the spring doesn't have much tension in it, so that's a sign that you would want to replace that component. So once you're satisfied with the brake assembly, either you said you decided to replace discs, or maybe you didn't have to replace anything, you're just doing it as a preventative maintenance, looking it over. We do recommend, I recommend yearly on a hand hoist that you look it over. It's pretty simple to do. It's not required by ASME. They just say if ASME will say that if the hoist is functioning properly, then the technician doesn't have to go into it any further than need be. And it can be done while the hoist is hanging in place. But you know, I do recommend it. They're so simple and they're easy to get down, and usually you can inspect them pretty quickly and get them back up and running. So so reassemble in reverse order, and then once you turn that hand wheel back on, you want to hold the chain as tight as you can. And so what you're doing is you want to put some tension on that brake, or pre-tension it, to seat it back down before you put that castle nut and cotter key back on top. And then once everything's reassembled, you want to hang that hoist, and you want to put a light load on it, and you want to put at least 50 pounds times the number of load supporting parts of chain. So a single reeve hoist, which just has one part chain going down the hook, that would be 50 pounds. If I was double reeve, meaning 2 parts of chain are going through a hook block down near the hook, that would be 100 pounds, and so forth. So you can do the math. And what that does, it checks the functionality of the hoist. And if there's a problem, you're going to see that it won't even hold the light load. So you can check functionality and do an operational test. One of the questions I get asked a lot is a load test needed to be done after you disassemble brake? You know, it is a recommendation from CM that it's a good thing to do. The ASME specs will say if you're not replacing any load-bearing parts, that no load test is required. And a brake is not considered a load-bearing part. It's considered a transmission part. So technically under the ASME V3016 guidelines, no load test would be required. In my opinion, and CM also recommends, it's probably a good idea to do a full load test on the unit after you disassemble the brake. I personally would do it. It just seems to me that it ensures that everything is operating properly. But that operational test, that light load test, is very important to do as well. So you kind of want to do both. And so that's how simple, and basically that's how simple it is to do the Hurricane 360. It's a very simple brake, very simple inspection, and easily resettable.
Okay, Peter, I'm going to jump in for a sec. I'd like to go ahead and launch a polling question just to see, get a little feedback from all of you. All right, which of the following is a reason to replace friction discs? Wear, glazing, contamination, or all of the above? If you can go ahead and vote, that would be great. Which of the following is a reason to replace friction discs? Wear, glazing, contamination, or all of the above? It's very interesting. Looks like it's between wear and contamination, and there's a chunk of you that are voting for all of the above. Whoops. Okay, I'm going to go ahead and close the poll. It looks like 21% of you said wear, 11% of you said contamination, and 74% said all of the above. Peter, can you go ahead and share the answer?
Yeah, all those would be a reason to replace the friction disc, all of the above.
Okay, perfect. Thank you.
Okay, and before I get into the short handle puller, I do want to make note that anytime you're working on a hoist, it's advisable to read through the maintenance manual of that particular hoist or lever tool or chain fall electric hoist. And CEM does have them all online in their library, so you just go to the CM Works website and you can go to the library and you can download any maintenance manual for these hoists. So it's a very good idea to also read through those maintenance manuals. So let's get into the load brake inspection on a short handle puller. It's similar but a little bit different. What is the short handle puller, so everyone knows what we're talking about? Well, it's a lever tool. It can go up to three quarter up to 3 tons. Again, it's a made in the USA hoist that we make in our Damascus facility, and it's basically you can use it for positioning, moving things into place, closing doors, short minor lifts, pulling pipes together. So you can use it as a hoist for small lifts. Obviously, you're not, for longer lifts, it's probably more advantageous to use a chain fall or an electric hoist. But it is a hoist. And a lot of people don't realize that a lever tool is a hoist. So it can not only can it be used for pulling and tensioning, it can be used for raising a load. So it's small, compact. The nice thing about the short handle puller is that it's weatherized. It's not like a typical import design where it's all wide open where you can see into it. And so it is weatherized. It's fully enclosed, and this tool is made for precise positioning and micro inching. So it's a very, very nice tool. So let's get into the lever tool here, the short handle puller. So the cap is going to have 2 Allen screws, so that where you see that CM there on that cap off to the left, you just take those 2 screws off, and the handle will come right out. Okay, and so there you can see that the brake hub is exposed, and that's pretty much what the chain wheel looked like, or the hand wheel on the chain fall looked like. It almost looks similar, except it doesn't have chain, doesn't ride in a pocket. It's where the lever sits, and so we're looking at the brake hub right there. So we want to take on the short handle puller. There are 2 pins, so this is a little bit different. So after we remove that cap, we want to remove those 2 pins, okay? And those are the brake locking pins. They come right out, and so you can see in the picture to the right, the 2 pins laying there next to the brake hub. Okay, so all we got to do is, once we remove those 2 pins, is turn the brake hub counterclockwise, and it'll come right off. It'll thread off that pinion shaft. So it's very similar design. Okay, so we want to inspect that hub first and those pins, make sure there's no wear or they're dented, things of that nature, or bent. And then on the back side of that hub, just like we looked at on the back side of the hand wheel, same exact thing. We're looking for contamination, surface rust, anything that's causing us concern, we want to try to clean it up. And again, the internal threads of that brake hub needs to be a light film of lubrication on there. So we want to be sure that that brake can open and close and it's not binding up on the pinion shaft. So to remove the brake cover, we have another two Allen screws that will remove the cover to the brake. And you can see on the short handle puller there is a seal on the outside. That's where I talk about where it's weatherized, it's fully enclosed. So if you're working in a mining environment or a lot of dust, things of that nature, that's what it protects it from all that stuff getting inside there. So it's a really advanced type of lever tool, so it can protect it from a lot of contaminants. So we want to look at that seal, the integrity of the seal. And then we can look at the components. So again, it's the Weston type brake. So we're looking at a friction disc, a ratchet, and a brake hub. Those are all the components. And it's the same exact inspection that we did on the 360 Hurricane, except the discs are a little bit different. These discs are made of metal, where on the Hurricane, the discs were a composite material that was pressed together. And so these discs, if they do get contaminated, they can be wiped off because they're metal. So you can wipe off oil from them. So again, it's a little bit more of an advanced tool. So we use a specialty type of steel for our friction surface. And the minimum thickness on that is 0.075 inches on those discs. As you can see, metal is not going to wear as fast as a composite material, so you're not going to get the brake dust, things of that nature. So it's a little bit more of a high-end type brake that you see there, so which I like a lot. You don't have to worry about oil contamination on the discs. You do have to worry about, as far as you can clean them, but you do have to worry about that oil gets on those surfaces because it could affect how the brake works. But you wouldn't have to throw the discs away if that happened. You would just have to clean them up. Okay, so but the exact same inspection that we did on the Hurricane 360. And then, of course, the pinion shaft we're looking at for damaged threads, and again, the light lubrication that we have been talking about, and the ratchet pawls we want to inspect as well, and the spring tensioning. Again, and there's your full-blown brake inspection. However, assembly of this unit is a little bit different and unique, and I want to talk about that because it is a precisioning tool, and it's a very precise tool, so it is a little bit different how we assemble it. So we're going to assemble it in reverse order, like we said, so we put everything back in reverse order until we get to that hub and the pins, and this is where it's critical that we understand how to set. So there's a unique setting to this lever tool and how to get that brake set right. And what it is we set it so that when we open up that gapping so that the load can come, we can lower it to the ground, that it's set right so that we don't open it too much. And we're going to go through how to do it. So we take that brake hub, and there you can see the first picture there is without the hub on there. And you can see there's the pinion kind of, we're looking at a bird's eye view of that pinion shaft looking at us. And then I do want to make note here, these black right here, these black bumps right here are the stops, okay? So that's going to be critical. I also want to make note, make sure those pawls are seated properly within the sprocket. So we're going to screw that brake hub back on clockwise until everything is tight, okay? And then we're going to put those pins back in, those locking pins. And those pins are shown right here. So here's a locking pin here, and here's a locking pin here. And then what I'm showing in this picture here, once everything is tight, when you tighten it down clockwise and you put those pins in, then you go counterclockwise, and what will happen is that pin, in this picture it was here, so we're showing it rotated around to this position where it actually hit that stop. So basically, if you look over here, it was here and rotated all the way around to here until it hit that stop. That is too much. That would open the brake up too much, and we don't want that. We only want a 10 to 45 degree movement of those pins. So what happens when you screw that back down and you get that much of a movement when you turn it counterclockwise? It's not going to function properly. And I'm going to try to explain that one more time here in a visual, another visual. Whoops, let me go back up here. Oh boy, hit the wrong button, so bear with me quick. There we go. Here's the brake hub here, and I'm going to kind of get out of presentation mode so I can show this. And you bring this brake hub onto your pinion shaft, okay? And once you're on there, it's got a 4-lead thread start, and so you're going to go clockwise, and you're going to screw this all the way down to it's tight. So it's going to get tight. It's going to lock in. All right, and then you're going to put your locking pins in these two holes here. And we'll see if You're going to put in this hole here the locking pin, and you're going to put the locking pin back in those holes. Once those locking pins are in, you go counterclockwise and see where you're moving. So this is about as much movement counterclockwise as we'd like to see, right about there, 10 to 45 degrees. If it goes too far, if we see it goes all the way around like that, that's too much. So we have to reset that brake, or we have to adjust some things. So what do we do there? And let me get back into the current slide, from the current slide here. How to readjust that? So you're going to have to take the brake back apart, and you're going to have to raise up that hubs just till it clears those splines on the pinion shaft. So you can see the splines in the bottom there on the pinion shaft. So that hub, raise it up just enough to clear those splines. If you're more than 45 degrees, you're going to rotate clockwise towards where those pins landed, and you're going to set it back down, okay? And then that will get it close, and that will close the gapping up a little bit more so that you don't have such a good big opening. If it's less than 10 degrees, obviously we want to go counterclockwise and move those stops away from where those pins are to let it open up a little bit more. So that's how you would set it. So it's a little bit of playing around to get it right, but once you understand how to do it, it's very simple, really easy. And it's done that way because it's a precision type lever tool. There really isn't any tool on the market that competes with it to be that precise. And if, a typical import design can't do what this tool can do. It can't be used in dusty environments because you get brake contamination. So it's that simple for the tools. There isn't much to it. Again, you've got to go through your pre-operational inspection once you reassemble it. On lever tools or lever hoists, it's 100 pounds times the number of load supporting parts of chain. So in the view to the right there, that's a single reeve. That would require 100 pounds to check the operation of that off. If it was double reeved or 2 parts chain going to that hook, then it's 200 pounds and so on and so forth. You can do the math. But and then again, a load test is optional. We recommend it. The ASME specs say if you don't replace load supporting parts, brake components are considered transmission parts. So a load test wouldn't be required, but we do. CM recommends it. In my opinion, I think it's a good thing to do a load test to really check it out. But those pre-operational tests are a good thing to do to be sure everything's seated properly.
Okay, I'm going to take it from here, Peter.
Okay.
We'd like you to go ahead and think of some questions for Peter. And while we're doing that, I have one more slide, quick poll I'd like to run for you. How much should the locking pins on the short handle puller be able to rotate before hitting a stop when the brake is assembled correctly? And I forgot to mention, for those of you who have iPads and are watching this on the iPad, you can just put your comment or your answer in the question and answer pane, because I don't think the polling works on iPads. But for the rest of you, you can go ahead and select 2 to 5 degrees, 10 to 45 degrees, 10 to 90 degrees, or 90 to 180 degrees. If you can go ahead and please vote, that would be great. Again, how much should the locking pins on the short handle puller be able to rotate before hitting a stop? Oh my goodness, this is very interesting. You really, you did a great job communicating, Peter, because we have 100% voting for 10 to 45 degrees.
Very good.
I'm happy to say. So excellent job, everyone. All right, I'll go ahead and close that, and then you can go back to that slide. Great. So excellent. Yes, we see. I see who's on an iPad. Yes, so we really had 100% got the right answer. That's good to see. So please go ahead and share your questions. Maybe you can go ahead and proceed to the next couple slides quick as questions come in, Peter.
Yeah, I do want to make note, this is a sampling of the things we do in our chain hoist repair technician schools that we offer. Obviously, we do it hands-on. You have the hoist in front of you, and you work on these, and you learn how to set it. And we, go through the same exact instructions for each and every hoist. Now, we just did a small part of those inspection of a hoist, just do the brake, but we totally disassemble everything and go through it, every possible wear area and what to look for and how to repair them, put them back into service safely, and do the load testing and things of that nature. And so if you're interested in learning from manual hoist to chain hoist, electric, air, wire, and the big wire rope hoist, then certainly come out and take the CMCO Chain Hoist and Repair Technician Certification course. It'll really help you go through and by the end of the course, you're pretty much know exactly what to do, what to look for, or how to reference the manuals to figure out how to do it. Secondly, the rigging crane operator, train the trainer. So if you want to learn how to rig, those of you who are crane installers, if you're erecting new cranes or putting things up there, well, you really do need to know how to rig, and you should be qualified to do that. So or if you're in construction or doing any type of industrial rigging, come out and take our rigging course. You don't necessarily have to take the train the trainer. You can it'll be 1 day shorter, but you can come and take just a rigging course with us. And you can see the dates there where our up-and-coming trainings are being offered.
Great. Excellent. Thank you. All right. And we did have one question come in, and that was regarding the, just one second. The question that came in was, how do we clean the friction disc on the short handle puller and hurricane hoist? So how is the friction disc cleaned?
Well, they're two very different discs, and that's why I showed the two. On the Hurricane 360, it's a composite material, so really the only way to clean it is to get a very fine grit sandpaper and sand them down. What works best if you actually glued the sandpaper down to a flat surface, and then once that's down there, you would you go in a circular motion and rub the friction discs on there on either side to clean them up, and then take a measurement of that friction disc to be sure it's not beyond its minimum wear criteria that was set forth by CM. So that's the only way to clean that disc. On the short handle puller, they're metal discs, so you won't be able to sand them down. So you could clean them up with brake cleaner and things of that on those metal discs. Again, you do want to take your minimum measurement, just as long as you have it out to be sure it hasn't worn down. But I can tell you right now, it's very rare we probably replace those discs on the short handle puller because they can be cleaned. Or on the Hurricane 360, if oil did get on those discs, if you're seeing oil, a lot of oil on those discs on the composite material, you should replace them. You shouldn't even try to sand them down. It's just for glazing and things like that, sanding them down works, but for a lot of oil contamination, you're going to have to replace them. But on the short handle puller, it's a little bit of higher end type of Weston type brake. You can clean them up.
Okay, and Peter, there was another question about the source of manufacture of the two products. Can you just touch on that real quick?
Yep, the short handle puller is made in the United States in Damascus, Virginia. The Hurricane 360 is made in our Chinese operations. It's a Columbus McKinnon plant. It's not something that we cross-brand. It was designed in Yale, Germany, and built in Columbus McKinnon China operations. Again, it's our plant. We own it. We operate it. It's our people that run that plant.
Okay. Thank you very much, Peter. I don't believe there are any more questions at this time. If you can forward to the last slide, I'll just touch on the couple of quick things regarding social media. And actually, I do have one more polling slide. I'll just touch on this quick, and then we'll go to the final polling slide. But just for those of you who are out and about on social media, I wanted to let you know that we do have a blog. You can find it at blog@cmworks.com. And we have over 150 articles about various things relating to our product, material handling news, industry news, customer questions and answers, things like this. If you're on Twitter, you can find us at CMCO Live for our industrial side, or CM Entertainment for our entertainment division. You can find us on Facebook at Columbus McKinnon Corporation. We have a lot of conversations there, picture sharing there, a lot of interesting discussions. Now, after this session, we will be loading this webinar on our YouTube channel under the category Webinars. So you'll be getting a link to that later this afternoon, and you can feel free to subscribe to us there so you get updates whenever we have new videos posted. You can also find us on LinkedIn. We have a LinkedIn corporate page, as well as on Google+. Okay, and I'd like to go ahead and run just one quick final slide, a final polling slide, just to gauge your interest. We wanted to find out, are you interested in becoming a certified chain hoist repair technician based on what you've seen today? And the answers are yes within 1 to 3 months, yes within 3 to 6 months, yes within 6 to 12 months, or no, I'm not interested. We just like to get a little bit of feedback to hear. But on that note, when you exit off the webinar, we just have a quick survey, one question. If this webinar interested you, the content, or Peter or anything else about it, we'd just love to hear a comment or two about what you thought about it. If you've been a regular attender or if this is your first time, we'd just love to get a little feedback from you on what you thought. So excellent. We really appreciate all the feedback on this poll. Seems like there is a bit of interest, and we're happy to see that. And as I said, we'd like to thank you all for coming today. I'll go ahead and close this. And if there are any further questions, feel free to go ahead and type them in. We are still looking, or if we miss them as we close out, Peter will be sure to contact you in that regard. But at this point, we'll go ahead and thank everyone for attending. And as we said, we'll be sending you a link to the recording later this afternoon. Thank you so much.
Thank you, everybody.